My name is Eric Hennefield. I work for Omron Automation in our industrial traceability business. And today we're going to be talking about traceability, or track and trace, or serialization, a strategy that you can help implement in your facility to help you be more productive long term. There should be some time at the end for questions, like she said. So if you want to hold your questions till the end, I should have plenty of time to get to them. And we'll go from there. Oh, we started at the beginning? Thank you. All right, there we go. We'll go over our quick agenda. We're going to talk about some things that are potentially causing manufacturers to think about implementing a traceability solution. What are the drivers? We'll talk about sort of the evolution of traceability. Where does it come from? Where is it today? And where is it going in the future? And the things you can look forward to doing with traceability in the future. Then we'll talk about some things, traceability standards, right? What are some of the standards in the industry? In automotive, there are a lot of standards. Some are around traceability and labeling and serialization. And other manufacturing industries, there are different types of standards and regulations to comply to. And then we'll talk about a strategy that Omron likes to implement and call the MVRC strategy. And it's really a methodology where you can easily and slowly adapt your manufacturing facility to have a complete serialization traceability solution. And it's not as hard as it sounds, and we'll talk about that. And then at the end, we're going to talk about something called Traceability 4.0, which is a play on Industry 4.0. It's Omron's term for how to sort of take your serialization and traceability information and where it crosses and intersects with the IoT or digital transformation within your organization to really start to take advantage of some of this information that you have and start to use it to make real-time decisions and take advantage of that information. So first, I'd like to start with a definition from Wikipedia on what traceability is. And the definition that it shows in Wikipedia is that traceability is really the ability to track something throughout a process and track and record and verify that information. So some ability to know where something is within your process and then record the information. So maybe it includes, if it's component assemblies, what are you assembling? What parts are going into it? What quality checks are you doing? What testing are you doing along the way? What's happening to that product throughout your entire process? And then record that information, hopefully to start to make some decisions or make some outcomes based on that. When we talk about, for intents and purposes within this discussion today, we're talking about what Omron refers to as internal traceability. So we're talking about the traceability aspects that you might find within the four walls of the discrete manufacturing area, or in this case, if you're in the automotive industry, what you might find for traceability and serialization on your automotive plant floor. So what does traceability really mean? Some people have heard this term TTC, track, trace, and control. And what that means is to track something, that means you want to know where that part is right now. What's at the station? What's at that manufacturing cell? What do I have in front of me? And what do I need to do to it, right? What am I doing at this particular moment? But there's also that trace. That implies, where did it come from? I want to know what's coming. I want to know what's been done to it previously. I want to know where it is and where it's going next so I can start to make decisions ahead of time to understand what I need to do and what potentially needs to be done to that part or that assembly. And then the most important part is the control piece, or where it's going next, right? So you can start to see if I can have an understanding with everything on my manufacturing line, which many of you probably do today in an automated facility, is if I know where something's been and I know where it is now, and more importantly, if I know where it's going and I can prepare that next station with all the information that it needs to make sure everything's been done properly and know what parts and components and testing equipment I need at that next station, right? If I have a flexible manufacturing facility, this is where the track, trace, and control information can really start to play into your hands as an advantage. And when we talk about track, trace, and control within the automotive industry, we talk about marking parts and marking individual components and being able to track those throughout your entire life cycle, throughout your manufacturing facility. It sounds like a daunting task, especially within automotive, where a vehicle can have over 20,000 parts that get assembled to make up that one assembly. Sounds like a daunting task, right? How could I possibly mark every part, track it through my process, and know what's going on? It sounds like it's impossible, but it's not. And we'll talk about how there might be ways you could do that and implement that today. So let's talk about some of the drivers or the reasons why one might want to implement a traceability solution. You know, there's a lot of things that can occur and reasons why. They have what we call internal drivers, right? There could be things internally in your organization. Maybe it's, quality control. Maybe it's highly customized ordering or configurations. In the automotive industry, we know that now customers buy with so many different options. You know, is it 2-door, is it 4-door? Is it all-wheel drive or front-wheel drive? Is that cloth or leather seats? There's all these different options that a customer can choose. And having a flexible manufacturing facility where we can switch back and forth easily and efficiently between those different models could be very advantageous for us, right? High precision product compatibility. Imagine if you're machining pistons in one portion of your manufacturing facility and later on you're going to match those up with cylinders in an assembly, right? Well, if you're measuring those pistons at the time of machining and you're finding that some of those pistons are still within your tolerance but maybe on the higher end of the tolerance, later down the line when you marry that with a cylinder, you want to try to match those up with similarly higher tolerance cylinders with those pistons, right? So it can help you be more precise, more high quality, more precision fit. Or there might be external reasons, which is usually what drives manufacturers to implement a traceability solution. It could be maybe the action group has got some standards that you need to apply or need to qualify for or need to be compliant with, right? Maybe it's label standards, maybe it's manufacturing standards, could be other things. Counterfeit parts is a huge issue in all industries, but especially in automotive, right? How do I make sure that I'm getting the right parts from reputable sources, made of quality steel that are coming in or carbon fiber, and how do I know those parts are high quality? How do I track that? How do I verify that? Traceability can help with that. Probably the most important or the most prevalent reason why manufacturers are implementing traceability solutions today is because of vehicle recalls. And this one is a very old one. I think many of you are aware of the airbag inflator recall. Now it's 20 years it's gone by, right? Huge impact globally on the automotive manufacturing and consumer market. Millions of vehicles affected, billions of dollars of cost went into this to try and repair it. And the reason I bring this up is not to rub salt in the wound or remind people, but it's more, according to NHTSA, today, still now, 20 years later, there are still millions of these vehicles on the road in service today that have these faulty airbag inflators. And it's nearly impossible to verify or make sure that every single consumer is going to go ahead and take that recall action and do that rework. And so this is still ultimately an issue for those manufacturers, those brands, to protect their brand out there because there's still these faulty parts in service. So it's very difficult to undo a recall. You can do the best you can, but the best chance would be to try to limit those recalls in the beginning or mitigate them altogether. And I think traceability can help with that. This is an excerpt from Plant Engineering magazine that I took, and this isn't specific to automotive industry, but I think it applies across the board. It's more, what are some mega trends within Industry 4.0? What are manufacturers wanting to do? What are they trying to achieve? And I've circled some spots there, so whether it's predictive maintenance, whether it's remote monitoring and predictive analytics, might be communication technology like wireless or 5G, or it's flexible manufacturing, right? And what I say is all of those have one common denominator, and that's utilizing data to make informed decisions. If you're not able to communicate data that you have at your fingertips, to access data across your entire enterprise, to connect your supply chain to your manufacturing facility, it's very difficult for you to start to make decisions based on that Industry 4.0 data, but you have access to it. It's there, and it's time to start taking advantage of it. When people think of traceability, I think it means a lot of different things to a lot of different people. So we're going to talk a little bit about really the start or the advent of traceability and kind of how it's evolved since then. I think most people can resonate with what we call traceability 1.0 at Omron. That's back in the 70s, if you're old enough to remember like me, when you started going to the grocery store and you remember when those products could get scanned across the grocery store like we still see today. So no more inputting data, no more manual error. We're scanning codes at the store and those things automatically get implemented and brought on. And then soon after that, traceability 2.0, we call it in Omron, then not only retailers, but now warehouses and other manufacturing elements, they could take advantage of that UPC code or that barcode on those products to start to make decisions about what's flying off the shelves, what do I need to stock more, how do I source more, where do I get the ingredients that I need to make that particular product or the components. So these started up, and this is really early days of traceability, but this really isn't what we're talking about today. It wasn't until about the 2000s or the early 2000s when this line and invisibility became prevalent. And that's where within the manufacturing facilities or within the manufacturing and ancillary portions of their supply chain, they started to get visibility and using those codes to their advantage. So now I can not only track all my incoming materials, I can track what leaves my facility. I allow my consumers potentially to have access to that data. I can start to gather all that information and utilize it under one database type situation. And then we get into where we are today, and we think this, Omron, we call this traceability 4.0. So if you've got all this information, you've got access to all this data, and you've implemented a traceability serialization solution, Why not start taking advantage of that data and really bridge that gap we call between what's called the IT and the OT, or different parts of our business. Start sharing that information throughout. And this is where that man, material, and method comes to play, the 4M. We can start to link that and really start to make internal manufacturing process decisions to help us improve our productivity, reduce scrap, improve OEE, and so forth. And we'll talk more about Traceability 4.0 at the end of this presentation as well. So again, I think everyone's familiar with this. Scanning barcodes, scanning packages, these labels, these barcodes have been around forever, right? It's very good information. It's easy to use. It's simple. It's error-proof. Very easy to get data. When we talk about the next phase of traceability, where again, on the outskirts, so on the vendor and the retail side, maybe they were using those barcodes, maybe they were scanning the information, maybe they're taking advantage of it, but there was a disparate gap in the middle in the production facility where there really wasn't much information going from what comes in versus what goes out of a factory, right? So between the manufacturing, the testing, the quality checks, the component assemblies, things like that, there wasn't a lot of information. There was a gap there. And we think Traceability 4.0 really helps remove or eliminate that gap altogether by implementing a strategy similar within your manufacturing facilities. And the other thing that helped along the way was that those barcodes evolved from being a larger barcode that takes up a little bit bigger footprint, that doesn't have as much ability to capture data. Now there's these 2D matrix codes that are available. They can store a lot more information in a much smaller footprint. So now you can imagine how you can start to put marks, like a 2D barcode, very small marks on different small parts. So you can really start to see the advantage of being able to read those from a distance, mark even small parts, and get a lot more information along the way throughout your process. We talk about some of the objectives or why you might want to do this. They're really endless. But imagine now part genealogy. So from the case of recalls, right? If I could track and trace a component from my supplier all the way through to my incoming inspection and receiving, all the way through my component manufacturing process, and all the way out the door to my finished goods and beyond, that gives me a lot of powerful information to help mitigate or at least track recalls, things like that, right? I could identify them more quickly, and I could take advantage of the information I have to make sure bad parts don't get out the door. Something else called spill containment is within the manufacturing facility. You're going to have issues, you're going to have problems, you're going to create parts or create assemblies or do something that either miss a step, miss a component, get the wrong component put in, something goes wrong. The sooner you can identify that and make the necessary adjustments, the better, because the further that goes down the line, that assembly, the more work you do, the more rework potentially you have to do, or God forbid you have to scrap that item and you've done all this extra work, the sooner you can contain that issue, the sooner you can use spill containment to your advantage by being able to track everything through your facility, the less rework, less scrap, less cost you're going to have, and better chance of not getting bad parts out the door, right? And this is applicable for all different manufacturing processes. It can be implemented in your production facility, can put in supply chain for your material providers, can be part of your quality departments, can be your business analytics, can be everything combined in here. Why not start sharing this information and using it? And when we think of Traceability 4.0, like I mentioned earlier, that's where you can start to get visibility into your manufacturing process. If you're marking every part, and you may not be doing that today, but if you have the ability to mark every part, every component, every single thing that you're assembling in your manufacturing process today, and maybe you're doing it for a compliance reason or for a customer specification or something else, why not take advantage of that information and start to use it internally to give those people, whether it's operators, whether it's maintenance personnel, whether it's quality personnel, the information they need exactly when they need it in a format that they can digest and do something with, right? That's the goal with Industry Traceability 4.0. Now let's talk about some of the standards and regulations that you might see in the automotive industry. And this definitely doesn't cover all of them. There are a lot of requirements within the automotive industry and more coming all the time. When it comes to what we call unit level DPM or direct part marking, there's some standards, whether it's a label, whether you're marking a part directly on the metal itself or on carbon fiber or something else, or whether you're using a label, there's definitely a lot of standards that you have to comply to. And they want to have those standards within the industry so that we have the same look and feel across manufacturers. We have the same type of information being presented so that our consumers and our manufacturers can be on the same page. And so this applies across the board to all different facets of manufacturing within automotive. It's not just powertrain, it's not just the electrical systems, everyone's complying to these particular standards. And we talk about standards, I think labeling is one of the most interesting standards in the automotive industry. It's very common, whether it's a VIN label or a VSC label or some other spec labels. You know, when you open the door of your vehicle, on the door jamb, there's those stickers that have a lot of information. Those are very much controlled and regulated. Not only, again, the information and what it lists, but where it lists it and how it's presented so you can understand what you're seeing. And if you ever have time to go through some of these, the Action Group or NASA even brought on some of these standards back in the 80s, but there's all sorts of different standards that go along here. And so one of the things that's interesting, NHTSA has a website that's free to use. Everyone can use it. So if you're bored some evening and you want to find some information on traceability recalls or label issues, this is what I do sometimes just to see what's going on. They have monthly reports that they put out. And it's amazing how many different issues that you can find in the NHTSA website for label recalls and issues that are caused by incorrect marking or labeling. So for instance, in August of last year, the incorrect towing capacity was listed on one of the labels on the vehicle. Now obviously they can just print a new sticker and send that out and inform the consumers there, but in case somebody uses that vehicle in the wrong way or they overload that towing capacity, it could be a safety risk. It's hard to get that back, right? So making sure you have the right information on the label is very, very important, and we'll talk about how to do that later. In February of this year, incorrect tire pressure was listed. I think in this case, out of the 4 tires, 3 of the tires were correct, 1 of the tires was incorrect. That shouldn't happen, and you should be able to verify those label information is correct before it ever gets anywhere near a vehicle to be putting on your product. There's easy ways to do this to verify that you have the correct information. Another one here, this is interesting, the incorrect component was added during a manufacturing assembly. So they were using traceability, they had serialized all their parts. As it came through, they had an incorrect label on one of their parts, incorrect information, which caused the production facility then to try and attach the incorrect components downstream. Again, ultimately so important to make sure you have the right information in the beginning. There's no reason to go any further until you verify that information on that label is correct. And then the last one, this was interesting. There were vehicles found that had 2 different VIN numbers on the same vehicle. Now that's something that should be easy to catch and should never happen. You should be able to cross-reference and make sure that you never have that issue. But you can imagine how bare minimum what a headache this would be for those manufacturers to recall and the costs that are associated with it. But it could lead to a lot of liability issues as well, right? It's beyond just the label being wrong. It's all about brand loyalty and protection in this case and cost. So now we're going to get to something called, Omron refers to as MBRC. It's a methodology. You're saying, Eric, I don't know how I could possibly consider marking every single component in my factory and then using that information. It sounds like an impossible task. Well, I'm here to tell you, you can start small. It's not that bad. It's not that invasive. And what this is this just our methodology to help you understand, what's involved with implementing a traceability solution. So first, you got to mark stuff. You got to put a mark, whether it's a label, whether it's a 2D code. You got to mark every single component, if possible, in your manufacturing assembly. The more you can mark, the more you can track, the more information you can glean from that particular process. And there's a whole lot of different ways to mark things. We've talked about a couple, direct part marking and labeling, but there's a lot of different ways you can mark products. And depending on the environment, if it's a harsh environment, a direct part mark usually lasts the life of the vehicle and beyond. It'll be very robust throughout your manufacturing process where a label might not be. So there's different options to consider, but marking every part is something you should consider. And this is what we talked about on the last page with verify. You need to verify those marks are correct, whether it's a label you're printing or a mark you're putting on a part, and not just verify that the information is populated and it looks like it's in the right spot and the quality of the mark or the label is good, it doesn't have any wrinkles or you weren't running out of ink or any ghosted prints on there. You need to make sure that that information there is correct. And there's an easy way to do that with a verification system. As a matter of fact, if you see that printer there under the V, that printer, that label printer actually has a verifier built into it that looks at the printout as it comes out for each label to, again, not only verify the grade or the quality of that print, but make sure every single piece of information is not only located in the right spot on that label, but is correct 100%. No reason not to verify every single label that you print out. And then you want to read these codes or these labels throughout your entire process, every single station, every time a component comes in, every time you have an assembly process, every time you do a quality test or some sort of system check, read that information. So again, you're tracking it, you're tracing it, and you're controlling it throughout your entire process. No surprises. And not only does that next station know what assembly is coming and what I'm going to do to it, but when it gets there and I read that code, it verifies exactly what I expected to see. It's very hard with redundancy to make mistakes. It makes it a lot easier to avoid those. And then this is probably the least talked about portion of this segment, right? Because I mark everything, I run it through my plant. Yes, how do I start communicating that information, using that data to start make more informed decisions? And we'll talk about that a little later with this Traceability 4.0 idea, but that's where the power really is for you as manufacturers to start take advantage of this information. One thing we've talked about so far is how to mark products either directly or with labels. There's another way to read and write information to products, and that's using RFID technology, or radio frequency identification. And RFID is different than optical, so you can understand with optical you need a camera or something that can read or scan a code. You have to have line of sight, you usually have to be close proximity to that label. You can't have a harsh environment, maybe dirt or dust or water in there, right, that could get in the way. RFID has a lot of advantages over that, where you can place a physical tag. Usually it's on an assembly carrier or something, not necessarily on the part itself. But those tags can be reused. You can put them through paint. You can put them in harsh environments, and they can be read at much longer distances. So you can really be able to still read and write throughout your entire process. The other cool thing about RFID is that not only can you read what's coming, so you can have a scanner read what's supposed to be there, but now you can write information back to that tag. So you might be sending information to your database to make sure you're cross-referencing it to be correct, but you can also send that same info to the tag so it's following along with that product. So again, you're getting that redundant information. And so you can mix and match these technologies. You don't have to choose one or the other. You can use barcodes with 2D codes, with RFID. You can mix it all. I just didn't want to leave that out. If you think about a simple traceability system implementation, this is a short video that kind of explains how one could use direct part marking, labels, RFID all together and sort of put an assembly together.
This video further shows the concept of using traceability to control the production of a typical automotive subassembly. Here we are seeing an alternator housing that has been fabricated and is being serialized with a direct part mark. The automation controller is passing the serial number to be marked to the laser marker controller via Ethernet IP. Next, an integrated vision system inspects the mark and sends that data back to the controller to confirm that it has the proper quality. With the serial number and the part ID information, the controller now knows which tooling is required for the next step of the process, which in this case is drill bit number 3. The 4 required holes are drilled, and upon completion, information is again sent to the controller indicating that this step has been completed. Next, the housing is placed onto an RFID tagged assembly carrier. Once in position, the tag is read and the ID of the tag communicated to the controller, which recalls the assembly requirements based on the information on that RFID tag. The correct mating parts are identified based on the tag ID and checked against the higher level assembly serial number for the product to be built. The required mating parts of the assembly are identified, positioned, and once they've been assembled, that information for the serial number is written to the carrier RFID tag and pushed back up to the MES via the controller. The required fasteners and their assembly torques are recalled, after which the tools finishing the fastening with the actual measured torque values are checked and they're archived back up into the production database. Finally, a smart camera archives the image of the assembly serial number and checks the barcode for accuracy, sends the product information to the production database along with an image of the part which has been manufactured.
And I know what you're thinking. You're thinking you're really going to mark every single bolt, every single item that goes into that assembly, and you're really going to track it back to every tool you have and make sure you have assurance of what's going on. And yes, I'm telling you, you can. And it's not that difficult, and we can show you how, but that's the plan, right? And not only are you able to gather that information, and we keep talking about storing it in a database, again, for historical look back or recall prevention, but there's a lot more information you can glean from that data that you can start to use to your advantage as well. So if we talk about Industry 4.0, or what we call an Omron Traceability 4.0, how do we help manufacturers take that data that's at their fingertips that they're probably using in their production floor now, and maybe it's running to a PLC and that's about it? How do you take that data and then use it differently, use it more often, use it in real time? And that's what we're going to talk about next. Because in a manufacturing facility, in this global economy, in this environment, there's so much going on. And we also know there's a lot of headwinds facing manufacturers today. I use a term, this is my why statement, is called manufacturing matters. What gets me out of bed every morning is I want to make sure that I enable manufacturing facilities to thrive today and in the future. I think manufacturing facilities are pillars in our community. They employ our families and friends. They put a lot of money into the economy through salaries and taxes. They educate through apprenticeships and internships. They donate to charitable contributions. We want manufacturing facilities to stay open today and in the future within our locations. And with the workforce shortage that we're seeing, the people leaving the workforce definitely don't have the same competencies and capabilities of the people entering the workforce. With demand increasing every day and with the equipment on our plant floors getting older, I'm not telling you need to rip and replace and start over. I think we can, through automation and through traceability, and we're not talking about replacing people, we're talking about enabling those new workers that are coming to our factories to be more proficient with what we have and work with and be able to meet that demand that our consumers are demanding. And so again, when we get back to the MVRC, let's talk about the C. Let's talk about how to take all that data and start to make use of it. How do we easily communicate it? How do we use it to our advantage? And again, has anyone ever been in a factory, whether it's recently or in the past, where you've seen either maybe it's a machine operator or a maintenance person, or maybe it's a plant manager going around with a clipboard and manually logging data, and maybe that clipboard then sits on the machine or goes in the maintenance office, something like that. Now imagine how difficult it would be to take that information that's being logged manually, which still happens today all the time, by the way, take that manual information and actually try to do something with it to make an impact on your facility or beyond. It's really challenging. You have to digitize that. You have to start your digital transformation today. You have to take that information, put it in a format that you can start to add other pieces of information to get a bigger picture of the overall performance. Real-time data is what you want to use and have access to. So now we're going to kind of finish up talking about what we call Traceability 4.0 within Omron, and this is kind of the culmination of everything we've talked about. How do you take that, connect that information, pull that data, and utilize it, and by the way, then present it in some sort of format with a picture that allows the right people to utilize it at the right time, right? So whether it's, again, genealogy, preventing counterfeit, improving quality, reducing scrap in this era of material scarcity, we would hate to have to scrap products or because we did incorrect assembly or did something wrong to that process when it's really hard to get those components on the front end, right? We want to error-proof each step. We want to make sure what we do is really preventing any bad quality parts from getting out and keeping that manufacturing system secure and up and running all the time. So if you talk about the benefits of Traceability 4.0, here you can see a manufacturing line. Now you can imagine that within that line, there's probably, at each machine cell, probably a bunch of devices, smart devices, other devices that are communicating data in some form or fashion back to a controller. Maybe it's to a central cabinet. Maybe those cells are separated and they have their own controllers. Regardless, there's not always a lot of connectivity between cell to cell or information flowing freely between. But maybe you are. Maybe you're doing that today and you're communicating that information through your cells across the entire line. Are you communicating that information from line 1 to line 2 to line 3? Are you then taking that information, maybe you have multiple facilities, and sharing that information? If you run the same line at this plant as a line at this plant, how can you help them improve by comparing data and utilizing different facets of your information? How do you connect this information to your supply chain? How do you get your vendors involved? How do you help your inventory control management and procurement utilize this data to start making better decisions with what's being manufactured on the plant floor? All of this is possible. When we talk about manufacturing, we've heard of this term called reducing the gap between the IT and the OT. It's a very common statement we hear today from the IT side of our business, or maybe what we call their level 3, level 4, to the operations side of our business. So most of the manufacturing facilities, they live and breathe at that level 1 area. That's that machine, that line level. That's the plant floor. That's the production line that we see every day in a manufacturing facility. That's where all the devices, all the sensors, all the conveyors, all the motors, all the robots, they live and breathe, level 1. And then at level 2, that controller or that SCADA level is what controls all those devices and kind of keeps track of everything, makes things keep moving, make sure we're doing the right things at the right time and triggering certain things to happen. And then between level 2 and level 3 and 4, there's a big gap. Level 2 and 1 kind of work together, and then level 3 is your MES, so where you're maybe executing your work orders, making sure your materials are allocated correctly, making sure you have the right people and the machines uptime and operation available to do the job. And then level 4 is more that ERP or enterprise level where maybe you have business analytics, your supply chain, and other things involved there. Level 3 and 4 are very different and disparate from level 1 and 2 today in most manufacturing facilities. They don't share data, they don't talk a common language, and they don't have a lot of communication interoperability, but they should. And with Traceability 4.0, we can really help bridge that gap between what's going on at L2 and below and what's happening at L3 and L4. And with Omron, we have a couple of unique opportunities in this regard. So for example, MQTT is a data protocol, along with some of these others. MQTT is a data protocol that's very prevalent in the IT side of our businesses. If we're on the plant floor, we might never have heard of it. But MQTT is something that IT professionals live and breathe every day. And it's not so obvious or prevalent on the manufacturing floor. But what if I could tell you that you could take, with a simple device, you could attach to your existing architecture, you don't have to upset any of your plant floor operations, don't have to replace your PLCs or your devices or anything else. If you could put an edge device on there that would extract the data from your existing PLC and then communicate it directly in MQTT protocol, for example, with no middleware, no other hardware needed. It's that simple. So we're not going to tax or overburden anything that's already on the plant floor. You don't have to reinvent the wheel. You don't have to rip and replace. Just add an edge device, start gathering data, and then communicating it to different sources. You want to put it in a SQL database? Do that. You want to communicate it in MQTT to the MES system? Do that. You want to use OPC-UA because that's prevalent? Communicate it that way. And you have the ability to do this, and it's really easy. We talk about leveraging data to make informed decisions, right? So whether we're talking about reducing costs, improving our lead times, right? Knowing what we have and what we can build and how to get it out the door quickly, our production quality, all those things. And what it comes down to is communicated data equals value. If you're not taking advantage of this data, you're missing out on value. It's a competitive differentiator that you have at your fingertips. And it exists today on the plant floor. This data is there. Whether it's quality assurance. Imagine trying to do root cause analysis on something without having this information. It'd be challenging. With this information, it should be easy. It should be seamless, very transparent. And we talk about the business value and maybe the driver at the end of the day, whether it's descriptive diagnostic analytics or maintenance or whatever we want to talk about, there's really a method we want to follow, right? Today we might know what happened, right? But do we know why it happened? That'd be great. More importantly, what will happen, but why wouldn't we want to even control? Instead of predicting what will happen, let's control what's going to happen. Let's make the decision that not only do we know what's going to happen, we know when it's going to happen, we know where it's going, we know what's going to happen next. With Traceability Solution, you have the ability to do that. Implement your own control, own your own destiny on your manufacturing floor. And here's a video that kind of sums it all up, that shows maybe Omron's overall Traceability 4.0 strategy. Put some things in perspective for you. I have one slide after this, and then we can get to questions, but hopefully this makes a little more sense of what this crazy guy Eric's been talking about for the last half an hour.
Find your next success in the age of Industry 4.0. Let's talk about the fundamental elements of global manufacturing. As manufacturing has evolved with the increase in complexity, speed, and automation, the need to control and have visibility into the process has only increased. An average car has 20,000 parts that must be marked and traced, and even the smallest wearable is a maze of components, with each being essential to overall product quality. Our vision has always included the harmony between people, technology, and machines. Introducing Omron Traceability 4.0. Although related to Industry 4.0, Omron's Traceability 4.0 is different in several ways. We not only connect digital and physical technologies to optimize and improve yield, but also bring an added dimension, ensuring quality components and end products. Traceability 4.0 brings together information about people, process, equipment, and parts. Our connected devices communicate data seamlessly with each other across multiple data layers within an organization. Omron is a leader in manufacturing traceability solutions with a complete offering of products and technologies to help you mark, verify, read, and communicate data in real time. Why? To help you achieve the highest level of manufacturing excellence. The goal of Traceability 4.0 is the union of product, component, and supply chain tracking with machine and process visibility. Imagine seeing everything you need to know across your entire process, every part and product component, including real-time genealogy data. Traceability increases productivity, enables regulatory compliance, quality control, and protects your brand. Over the past 50 years, Omron has provided leading-edge customer solutions through each evolutionary phase of traceability. We are uniquely positioned to provide significant and innovative value to our customers in this space. Our proven strengths deliver reliable Traceability 4.0 solutions today, meeting the needs of customers and industry applications. Omron has been driving advancements since traceability's early beginnings, and we will continue to drive that evolution forward to benefit our customers. Take on a whole new view of your enterprise to better drive your manufacturing and automation decisions. Let Omron show you examples of our successes, discuss with you how we can simplify your application, and demonstrate how we can help you attain Traceability 4.0. Omron, your trusted partner in automation and your trusted provider of traceability solutions.
So hopefully that gives you a better idea of kind of what we're referring to here. So I like to use an analogy of the food and beverage industry, right? If we think of the food and bev industry, they have a lot of this implementation already set and a lot of compliance requirements in there. So you imagine when there's a recall on lettuce, for example, how the heck do they know where that lettuce not only ended up in the stores, right? They can start to use genealogy, but trace it back to the packagers and the producers, and then trace that back to the growers, right? It's a complete traceability solution because all of those entities have access to the same data and are communicating together in real time. And that's why they're able to mitigate or limit those recalls and find the genealogy quickly. You can do the same thing in other industries. This is something that's available and should be ready to go. And this final slide is really just to let you know that, again, this is doable. This is something, regardless of where you are within your digital transformation journey, you can do this. So if you haven't started at all, or you're figuring you need to do something, I'd love to access my data. I'd love to figure out how to do this. I promise you, you can do it, and you can start, and it's easy, and we can help. Or if you've already moved further along and you just want to advance what you're already implemented, you want to make some improvements to your productivity or focus on some specific initiative within your facility, and you have a digitization strategy already started, we can help there as well. There's a lot of things you can do to maybe up your game if you've already gone there. So regardless of where you are in your digital transformation journey, it's never too late to start. And I would recommend you try and do something. Again, you don't have to rip and replace. You don't have to reinvent the wheel. You can do this. You can do it in small doses. You can do it how you want to within your facility. And you don't have to interrupt your processes to get this done. And with that, I think we have a little bit of time for questions. Again, my name is Eric Hennefield. We have an Omron booth. Whitney, what's our booth number? I should probably know that. 314 is our booth number if you want to come and chat or see some of these devices that we have that read codes and write product material. If you want to talk to me, I'll be here all day. Does anyone have any questions right now, you think? Maybe wait for the mic to get there. Thank you.
Two quick questions.
Yes, sir.
First of all, like the COVID variant, is it Omron or Omron?
So,
just kidding. My real
Omron.
question, it's Omron.
Omron, Japanese company.
Do you guys have a way of marking sheet metal that survives priming and painting?
That's a tough one, right? So you can do different things with the energy you use to mark, say, a laser mark on a piece of metal. So the depth of that mark, the more energy you put into the depth of the mark could last. It depends on what type of painting you're doing. That's a tough one. It's a tough one in the automotive industry right now. Sometimes it works, sometimes it doesn't. A good option might be RFID, which doesn't go directly on the part, it goes in the carrier. So it's a tricky one. Yeah, but it's possible, but in some instances, it's tough to make them still visible after you paint them. The option is to oftentimes, mark the code again afterwards or do a code mark after paint as well, which isn't desirable because you're handling the products more often. But right, that's a tough one. Agreed. Anyone else? No?
So with your RFID option, how do you verify the parts? You've got this concept of marking and verifying. If you're not marking the actual part, do you have to quarantine those parts and then some process? How do you...
So RFID is interesting because you actually, while you're not marking the part, you're actually able to write data to those tags that travel with the part. So it's like marking the part, but you can mark it in real time at every station that you're managing it, right? So The read-write heads that are used in RFID can not only read what that tag has to offer, like a code, and tell you what's going on, what it is and what I need to do, but then when you're done, say, with that particular manufacturing process, that head can write to the tag and say, here's what I just did, and here's when I did it, and here's where I'm going next. So now when it gets to that next station, I can read that again, but I already have that same information in my database. So you're getting redundant verification because RFID allows you to read and write both. So you actually get extra redundancy with RFID that you don't get, say, with just a code that's read optically, right? That's a one-way communication. So when I read a barcode or a QR code, I get the information, I receive it, then I cross-check it with data that I have behind the scenes. RFID, I can actually have the information reside on the part and in the database as well. Does that answer your question?
If we're not marking the actual part, how do you then down the road determine its pedigree?
It's a good question. So usually what people do is they combine, right? So they use RFID in a tough application, say like paint or some high temp applications where the codes might not be accessible or easy to view at that time, but the parts are still marked. So you can combine that data as well. So you can, if you don't have the ability to mark the parts, RFID is a great second option. But if you have the ability to mark the parts and use RFID, now you're talking about a game changer, right? You're getting redundancy and you're getting additional information. So if you don't have the ability to mark the part and you have to use RFID, you're right, it gets a little more challenging. You might have to implement additional quality steps or checks throughout your process to make sure that data corresponds with what I see in my database, but it's still doable.